Did you know that every day there are radio signals from IoT devices around you that you don't even know that are there? Did you know that you can take software and decode those? And you're probably wondering at this point, what does this all have to do with barbecue? This and more we will discuss with you. Tasty pork ribs, Sam. This and more we will discuss with you today as we start going through RTL-433, one of my favorite pieces of software. I'm Michael Smith, CTO type, CISO type, mad scientist type, and general radio frequency nerd. I'm joined today by Sam. Sam, who are you?
Hey, Sam Schneider here. Welcome to the channel, Security Geek Extraordinaire.
Outstanding. So, what does this have to do with juicy pork ribs? So, I have a device, and this is it's a ThermoPro TP20. Okay, and it has two pieces. One is this piece, and this piece has two plugs, and then it has probes, and the probes look like this. You stick them into your barbecue. This thing has a clip. It sits on whatever, on your like smoker or barbecue set or grill, wherever you want to do. You can even use it in your oven at home. And it transmits wirelessly. That's the important part, is that it transmits wirelessly. I have another bit, looks like this, that is, if I could do it right side up, that sits in my office or wherever I go. It's portable. It's got a little kickstand here. But this displays what the current temperature is, okay? And it receives the wireless signal. So on doing research on this, I discovered that this transmits on 433.92 megahertz, like a lot of different things, like toys, radio-controlled toys, drones, a lot of different devices transmit on that frequency, and that there was a decoding software that could actually intercept that and do interesting things with it. And that piece of software is RTL-433. So today we're going to go through what is RTL-433, how does it work, all of that stuff.
Yeah, what's really cool about this is, all of your gas meters, electric meters, things like that, water meters now are actually running on this frequency. And you'll actually be able to decode it and see some information on it. It's kind of cool.
Yeah, and that's why it's definitely one of my favorite pieces of software. I was teaching, and I still teach, an IoT software or IoT security course as part of a boot camp. And so I usually teach the IoT pieces at the end because we cover a little bit of Windows, a lot of Linux, a lot of Linux, some networking stuff. But to that, we added SDR. So our software-defined radio dongles, and a little bit of Arduino and transmitting signals via Arduino. So like always, I'm looking at things going, well, what else could I add to this in order to, add more material, teach things that aren't in the official book? And that was when I stumbled upon RTL-433. So give me a second to cue this up.
Yeah, well, Mike, while you're doing that, I'm going to also, after Mike shows RTL-433, I'm actually going to go and utilize the H2 PortaPack, and we're going to use the Mayhem Hub and show how we capture on the PortaPack as well, looking at ERT meters. Since we're kind of focusing on different signals around us, gas, IoT, different things, we're gonna actually look at it that way as well.
Yeah, and you'll see, like, I have a lot of utility sensors, sensors and transmitters on my street, and I pick up those a lot. So this is the page for RTL-433. Link obviously is down in the video description, like everything we do. And it provides a decoder. Okay. Now you can install it. It's got a build or a package for anything that's Debian based. Right now I'm running an Ubuntu. It's just an apt-get install RTL-433, downloads it, installs it, zero problems. Okay. But when you run it, it's got a lot of stuff that it can do. But if you look at the page and running for it, you'll see all the different devices. And there are a ton of them. It scrolls down. Last I checked, it was 258. Yeah. So 258 different devices. My device comes up as a ThermoPro T20. which is the same protocol as a T12, which it displays. But you see tons of different devices, weather stations, tire pressure management systems. So, right, if you think of like you're an engineer and you have tires on a car, you can't stick a wire to the tire because it'll twist up pretty quickly. So they put a wireless sensor in there that with a gyroscope that generates electricity, and it will measure the pressure in the tire and broadcast that over RF to a receiver that's in the car, and so that the car knows how much your tire pressure is, and it can give you a warning when it's too low. Now, it doesn't record or decode all of the signals by default. You'll see some of these like Lightwave RF. Here's a fun one. There are a couple fun ones like that are not enabled by default for various reasons. So ANT Plus is in here. ANT Plus is an incredibly chatty protocol. ANT Plus is what my Garmin watch uses to get sensors off, like my foot sensor. It's actually called a foot pod. That goes on your shoe that measures like how many steps you take, and a heart rate monitor, and measurements off my bicycle for how many revolutions per minute I'm cranking out or not. But ANT is incredibly chatty, so you don't want to grab all the ants, so that's disabled. Okay. However, just running this with the defaults can tell you a lot of stuff. So in order to, let me just demo this. I just created a directory here. I'll show you why I created a directory here in a bit, but you can just do RTL underscore, I can spell right, RTL underscore 433 dash F 433.92 M for megahertz. And you'll see it'll grab everything, start listening, and it'll take a couple minutes, and there you go, right? So it detected my ThermoPro set as a TP12. I have two probes on the device itself. Probe 1 is at 27.3 degrees, and temperature 2 is at 36.0 degrees. So as the SDR sits there, listens to that traffic, it will actually decode the signal and print it to the screen. So pretty cool, right? Like you can read stuff. And if you start messing with it, you can discover all the devices around you. So things that I didn't know were out there. My home, my security system sends out a beacon, right? And it just says, hey, I'm a security system. Here's my identifier, and nobody has tampered with me. Okay. And that helps the technician actually set up the device and set up monitoring through the phone line. Okay, so that's how they register the device quickly. My neighbors have a weather station that you can go and watch their weather station. Okay, you discover a bunch of stuff. And in fact, one of the things that I did is I created a temporary directory, right? So I just made a directory and I moved into it. I'll ls it here. I'll explain where this came from. This is kind of an eyeball chart. But RTL 433 allows you to do samples, and it allows you to do frequency hopping. Let's do frequency hopping first, because there are 4 key frequencies that I'm interested in looking at. One is, and it's dash F 315M. So 315 megahertz. It's used for older toys, some key fobs. So, you know, that officially they're called a keyless entry system. Some garage door openers, things like that, are on 315. F433.92, which is another low power devices, you know, consumer goods, consumer electronics kind of thing. So you'll see newer car key fobs are in 433.92. Other things like drones fit in, usually are 433.92. Another frequency was 868 megahertz. whoops, I have to actually write this correctly. F868M,
Got
and
a
I messed it
capital
up
F,
over
by the way.
here. Yeah,
Yep.
yeah, I messed that up. It's hard to type and talk at the same time. And then the last one, which is 912 megahertz or so, which is used. So 868 is used by a lot of European IoT, and some like the newer stuff that needs a faster frequency because they have more data. And then 912 thereabouts is used by a lot of stuff, including your utility meters. Okay, so I gave this 4 frequencies. I'm going to give it one more uh, flag here, which is H, and I'm going to see H20. And what that does with that capital H and a number is if it doesn't receive a signal, it will hop to the next frequency. So this allows me to monitor multiple frequencies and record or not record the signals, but display the signals from those different frequencies, and just kind of like a very restricted RF scanner. Okay, so it'll sit on one frequency, show any signals that it gets. If it doesn't find anything, 20 seconds later, it'll hop into another frequency, show me what it can pick up there. Doesn't receive anything, it'll move to the next frequency, and it'll just hop through all of those 4 frequencies, showing me what it is that it actually finds. Now, sometimes it will take a couple minutes for it to find stuff just because of the way that it's hopping. So it has to be on a frequency, and that frequency has to be active at the time that it's tuned to that frequency.
I turned this on earlier, actually. So this is what I had going on here. And what I'm seeing right now, I have a limited, lower profile SDR, not as powerful, but what I'm going to be picking up is all these gas meters that I'm currently in scope of. So you can see the gas meter, you can see the endpoint ID. Now that's pretty cool. That might or may or may not map to something like an ID on your bill. Go figure.
Yeah. In fact, I found this out with my bill. My bill has the sensor ID or the meter ID, which is verbatim the one that it broadcasts across the radio.
This is kind of interesting. So you have a tamper plug as well. So 808 or 0808 is listed on these. We would assume that that's not tampered with since all of them are preset.
I ran mine for a little while because I know that it takes time to grab all these signals. So I ran it earlier. I'll discuss this here in a second. But I ran the same command, grabbing all the signals, and you'll see I've got a really signal-rich environment. And we'll go through some of the things that I found. So I found ERT, which is utility meters. There's an official name for it. It's called an encoder, receiver, transmitter. And inside of the encoder, receiver, transmitter, you have SCM, which is what Sam showed. That is a standard consumption message. Really, really simple. Hey, I'm a meter. Here's my ID. Here's how much you used. Here's my current meter reading. Okay. And you'll see a bunch of these that came through. They have a type, which is what's the type of utility. I've got a lot of these that are, in fact, coming into my house is water, electrical, and natural gas. So you see a lot of these that show up. IDM is just a, hey, here I am, like broadcasting what its identity is and what it's used for. Same with NetIDM, same kind of thing. Here I got a Toyota. This is a tire pressure management system, so TPMS. And you'll see the current pressure is 36 PSI and the temperature is 23 degrees Celsius. This thing, it was funny. Month and a half ago, I got a nastygram from the water utility in my town. And they're like, hey, you need to set up an appointment within a week. Otherwise, we're going to shut off your water. It was awesome scare tactics. But I called them, set up an appointment. They sent a tech out. They replaced the meter that I had with a new meter. And if you go Google for a Neptune R900, just look up, Neptune R900, and you'll see something like that. Oh, you can buy them on eBay. That right there is exactly what he set up in my basement. So he just disconnected the line, hooked it all up, and that is the new meter that's in my basement. Okay. Other things that I found. Let's see. I got a lot of SCM Plus, which is a little bit different protocol. Let's see. I know I got a couple more tire pressure. Thought I saw it float by. But a lot of these things, because your ERTs, they show up periodically. Like once every minute or two. The smart meters will broadcast what their consumption is. This is designed so that somebody can take a reader, and they either have a handheld version or they have a version that's in a vehicle, an antenna sticking out of the vehicle, and they just drive down the street and passively collect all of the meter readings from everybody on that street. My street is about 40, 50 meters long. It's not a very long street. So they pull out the handheld module and they walk down the street, and I've seen them do it a couple times. It's really kind of interesting. Here's my ThermoPro again. Here's another Toyota tire pressure management system. But you see, like, you can run this and just passively collect all the signals that are around you, and that's kind of cool. The other thing, and I promised that I would mention it or describe it, is this right here. So RTL-433 has the ability to record signals. And so you give it the -S, and you can collect known signals, you can collect unknown signals, you can collect all signals. And what that does is, as it detects signals, as it decodes the signals, in this case, I told it to record known signals. So you'll see here, as you get a date, timestamp, the device, here's the human readable version. And then below, what it says is it saved it to this file name. And this is 97, 96, 95, 94, etc. So that's it just increments, like, what was the last number that was used. Then it gives you the frequency. So 912, 433, etc., etc. And then this is the sample rate. So how many samples per second? And then .cu8, which means that it's an 8-bit recording. Okay. And so that works pretty well. You can record all these. That's why if I come back here, Control C this, just do an ls in that directory, you'll see all of the samples that are sitting there. And RTL-433 has a lot of more advanced analysis that will let you go in and replay these. So you take a recorded signal, you run it through RTL-433, it will tell you and decode what that actual signal is, and then you can load it up into other tools to actually look at what is the signal that's being sent. And what you'll find is that a lot of signals start with 1, 1, 1, 1, 1, 1, 1, some series of ones. That allows the receiver to set their clock. So that's called the clock sync, right? And so it says here's 1 bit, 1 bit, 1 bit, 1 bit, so that the receiver can set its clock and know, like, how many milliseconds in between symbols, right? In between either a 1 or a 0. Then it sends something called a preamble, which is, hey, I'm going to send you an ERT standard consumption message. So each RF protocol has its own preamble that just identifies itself. And then after that, they have the payload. So you can take and record signals. You can look at what they are decoded. You can load them up in a tool. We'll save that for another day. One of the ones that I've used relatively large amount of time is called Universal Radio Hacker. You can load those 8-bit samples up inside of URH and then look at the clock sync, the preamble, and the payload, and build your own transmitter to send data, or even build your own decoder to be able to identify those signals when you see them elsewhere. Okay. that's pretty cool, and I like that. I think there's a lot more work to do with signals that way. But going back to you, Sam, you played with ERT earlier today. How did you do that? What did you do along those lines?
So, obviously using RTL-433, but using the HackRF as well. We wanted to
Yeah,
go back
yeah,
out there and use our friend, the HackRF PortaPack.
yeah. In fact, he said this was funny. So I walked Sam through setting this up. He's like, "Oh wow, I can find my meters. That's cool." And he's like, "I want to walk up and down the neighborhood with this thing." So he was talking like Raspberry Pi. I was like, "Look, I might have been in Las Vegas for a conference. I might have done several taxi rides, Uber rides, where I used RTL 433 to grab signals as I drove up and down the Vegas Strip. But then I said, you know what? You could just use your PortaPack to go grab ERT stuff. If that's all you want to do, you could grab that off of your PortaPack.
Yeah, yeah, absolutely. So I'll walk you through. We've actually gone through this in the past, actually setting this up, the HackRF PortaPack hub, the Mayhem hub, as you will. And we'll actually set up going through this. So I'm going to go ahead and connect my device to it. When I hit that connect, and let me actually go into the site. So
Yeah, and what's the URL? It's just
it's
hackrf.app.
hackrf.app.
Yeah, I will. That's a show notes thing. That'll go
Now,
there.
one thing you're not seeing because of how we share here, I should be sharing my screen, but when I hit connect device, I have a little pop-up window that's occurring here, and it says, hey, what serial port? Mine's COM3 in this case. I'm going to connect, and if you have your PortaPack up there, it's going to see it, and we're going to go into it. So you should be seeing that now.
Yep. Cool.
Awesome. Awesome. Now we're going to go into receive. I'm going to click into that, and we're going to go into ERT meter. So I'm going to click on that button, and now it's actually sampling. It's actually going out there and looking for ERT meter presence out there. And I've got this one dialed into 913.6. We could fine tune it a little bit more. If I clicked on this, we're starting to pick up data, which
Yeah.
is cool. Now we're seeing the type, we're seeing the ID information, we're seeing the consumption message that's out there, and any tamper codes and so forth. It gives you less data in this format, but for a handheld quick form,
Portable.
very, very nice. Very nice.
It puts the Porta in PortaPack.
Yeah, so I got a little neighborhood walk I'm going to be doing here in the next hour or so. I'm definitely going to be carrying this with me. See what I can pick up.
Yeah, one of the questions that I've seen in the PortaPack forums and on their Discord is, can somebody take all of RTL 433 and just port it en masse? And the problem is that RTL 433 has so many decoders, and each one has a different display. You could take an individual decoder. It's all there. It's open source. It's relatively well documented if you can understand C and understand directory structure and stuff, because each one of the decoders is just a device with a particular file. But because they display differently, it's really hard to put that into the screen of the PortaPack. So you could build a decoder for each type of device, but not all of RTL 433 into some kind of format.
Yeah, that's
So,
very
but yeah, it's been asked before numerous times.
interesting. But we'll continue building on this. I'm really interested to see what my walk around the neighborhood looks like. Honestly,
Yeah, I might have acquaintances, maybe not friends, but acquaintances, who go out and do war walking. So you remember back in the old days, you had Wardriving, you had war walking, where you were really looking for Wi-Fi devices. And in fact, there's a website that tracks all this called Wiggle,
yes.
where you can go do your war driving around, collect all the Wi-Fi signals, report them back to Wiggle, and they've gamified the whole process by giving people scores. They did the worldwide Wardrive, which was an event where the name of the game was capture as many signals as you could in, a 24 or 48 hour period. You could do exactly the same approach with RTL-433 and grab all of the IoT devices around you. Now, the default SDR for RTL-433 is going to be the NoElex. So it actually uses the RTL SDR driver for that. If you want to use a HackRF, the HackRF has to be in HackRF mode. Okay, so you put your HackRF PortaPack into HackRF mode, and in the command line, you add a little bit of magic to tell it to use the right driver, which is -d driver equals HackRF. Okay, and that will use the HackRF in order to grab all of that traffic. Okay, so it's just a little bit of a command line switch that tells it to use the right driver for a HackRF. It took me a little while to figure out. I had to dig through a lot of websites to figure it out. So I figured I'd put it in now and just tell everybody in advance.
So, it's really, really amazing the number of signals that's all around us. We have no idea they exist out there. Yep. And it seems like more and more appliances and devices that are in our home are IoT enabled, or they're sending out some type of RF signature. It's really interesting to go out there and see what's in your environment, where you have your exposures. Because let's face it, you can't fix, or you can't address a security concern within your home. Let's say you have a wireless thermostat that you're not aware of. You can't fix that, or you can't address it or research it unless you know it's there. So using tools like RTL-433 or the PortaPack are great steps in moving forward and understanding what you have around you and whether or not you need to remediate it or address it. Thanks for that great demonstration. This is my wireless guy right here.
So, having said all that, thank you, everybody. As always, I am Mike Smith.
And I'm Sam Schneider.
And we shall see you all in the next video.
C'est la vie.